All right, this is Algebra 2, College Algebra, first section in Chapter 6. And the section is on exponential growth and decay. So this is what the parent function looks like. It's b raised to the x power. You can't really see that x. And this is what they look like when you're graphing them. When b is greater than 0, or greater than 1, I'm sorry, this is what an exponential growth looks like. And when b is between 0 and 1, it would be a decay model, and this is what the graph of exponential decay looks like. Notice that in both situations, the domain is all real numbers, and the range is always y is greater than 0. The x-axis acts as an asymptote, and I don't know if you're familiar with that term. An asymptote is a line that the graph approaches, but never touches or crosses. So the x-axis acts like an asymptote. So the exponential growth model, there's the formula for that. And the only difference between the growth and the decay is minus. A is the initial amount you start with. R is the rate of change as a decimal. And T is the time. And it could be years, hours. Any problem you're going to do with this is going to specify what the time represents. So let's do a couple of examples. All right, so the value of a car in thousands of dollars can be approximated by the model y equals 25 times 0.85 raised to the t power, where t is the number of years since the car was brand new. Okay, well, first of all, let's look at this problem and ask yourself, is this growth or decay? So that's 0.85, right? And remember, the model is either 1 plus or minus r. Well, if in parentheses the number is less than 1, we know it's decay. And anyway, your car is not going to go up in value. And that's what we call depreciation. So we know it's a decay model. It says, and then we want to identify the annual percent of increase or decrease. Well, if this is 0.85, in other words, 85%, but we start with 100%, that means the rate of decay is 15%, right? Because 1 minus r is 0.85, so r has to be 0.15 or 15%. The third part of this question is estimate when the value of the car will be $8,000. Okay, so you're just going to set up your formula. So I want to know, remember, this is in thousands, so I don't have to say 8,000s, I can just say 8. 25 times 0.85 to the t. All right. So I'm just going to do this on the graphing calculator. And actually, all you have to do is enter this equation into your graphing calculator, the easiest way, I think, and then use the trace function and cursor back and forth with your left and right arrows until y equals 8. And when you do that, you'll find that x is approximately 7 years. So it'll take approximately 7 years to do that. All right, here's another common kind of problem you're going to find. the amount in grams of the radioactive isotope chromium-51 remaining after T days is modeled by the equation y equals A times 0.5 raised to the T over 28, where A is the initial amount in grams. What percentage of the chromium-51 decays each day? So here's where we're going to use our exponent rules to rewrite this part. So we start with this, and using the power of a power rule, I'm going to separate this out. Okay, because I can find 0.5 raised to the 1 over 28. And when I do that, I get this. But don't forget that this really represents 1 minus r, because that's part of the decay model. And if 1 minus r is 0.9755, that means that r is 0.0245 or 2.45%. And that's how much decays each day. Okay, another popular problem you're going to be dealing with is compound interest. And if you guys have ever taken the personal finance class that Marie teaches, I can't remember which one it is that deals with compound interest. This formula will look familiar to you. So this is the principal amount. It's the amount you start with. The annual percentage rate is R, written as a decimal. N is the number of times your interest is compounded in a year. So if they say it's compounded quarterly, then N would be 4. That's usually that's a more common amount. So make sure you have this in your notes and what they all stand for. And let's do a problem with that formula. So you deposit $9,000 in an account that pays 1.46% annual interest. Find the balance after 3 years when the interest is compounded quarterly. Okay, so N is 4 because it's compounded quarterly. T is going to be 3. And P is going to be 9,000. And R is 0.0146. So plugging all that stuff in, and I'm going to go ahead and do this first, and then raise it to the 12th power. When you do that on your calculator, you're going to have, after 3 years, you'll have $9,402.21. So in 3 years, if you left that $9,000 in that account that compounded interest quarterly at 1.46% annual interest rate, you would have earned $402.21 just by doing nothing with it. And that is it for 6.1.